In section 3, we're going to take a look at similar triangles. So just like when we were proving triangles congruent, we could use some special criteria. It works the same way with identifying similar triangles. We can look at 3 different ways to determine if two triangles are similar. The first being angle-angle similarity. So what that says is that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. And the reason why we only need 2 angles is because if 2 angles in our triangle are congruent, the third angles have to be congruent. So for example, if we have triangles PQR and TSU, and we know angle P is congruent to angle T, and angle Q is congruent to angle S, so if angle P is congruent to angle Q, angle P is congruent to angle T, and angle Q is congruent to angle S, then we can say triangle PQR is similar to triangle TSU. And the reason would be by angle-angle similarity. And we do normally put that AA to abbreviate it. So just like when we were writing congruent statements, when we write similarity statements, the order that we write those letters does matter. We want to make sure corresponding angles are in the same place when we write our similarity statement. We also have something called side-side-side similarity. So if the measures of the corresponding sides of two triangles are proportional, then the triangles are similar. So what that means is because PQ and TS are A and AX, so if I set up the proportion for all 3 corresponding sides, we get PQ over TS equals QR over SU equals PR over TU. Then we can say triangle PQR is similar to triangle TSU. So if we're trying to show that the sides are proportional, we want to simplify all of the ratios to make sure we get the exact same ratio. So in our example, we have A over AX should equal B over BX should equal C over CX. And if I simplify all of these ratios, the A's will cancel in the first, the B's will cancel in the second, and the C's will cancel in the third. So that'll leave us with 1 over X equals 1 over X equals 1 over X. So we have 3 ratios that are all the same, so the sides are proportional, meaning the triangles are similar. And our last similarity is side-angle-side similarity. So if the measures of two sides of a triangle are proportional to the measures of 2 corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So in our example here, we know the sides of PQ and QR and TS and SU. So the included angles would be Q and S. So for our side-angle-side similarity statement, we would want Q and S to be congruent. So we would have that if PQ over TS equals QR over SU, and angle Q is congruent to angle S, then we can say triangle PQR is similar to triangle TSU. So similar to the previous similarity statement, if we want to know the 2 sides are proportional, we look at their ratio. So we have A over AX should equal B over BX. The a's will cancel from the first ratio, the b's from the second, so we end up with 1 over x equals 1 over x. You may notice that 2 of our similarity statements are also congruent statements. The side, 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 and the side, angle, side are also used to prove two triangles congruent, but they are different. So they have to do with the sides being congruent, not the sides being proportional. So while we can use the same statement for congruence and similarity, their definitions are just slightly different. Let's go ahead and take a look at some examples. So in our first example here, we have in our figure that FG is congruent to EG. We also know BE has a length of 15, AE has a length of 9, and DF equals 12, and CF equals 20. We want to determine which triangles in the figure are similar. So let's start with the fact that FG and EG are congruent. So that gives us triangle, we look in our picture here, we have 3 different triangles. We have triangle BAE, triangle CDF, and triangle GFE. Well, knowing 2 sides are congruent in triangle FGE tells me that triangle is isosceles, which means that the opposite angles from those sides are also congruent. So we know that angle GFE and angle GEF are congruent. So angle GEF is congruent to angle GFE. And that's going to help us later on, because we're mostly looking at triangles BAE and triangle CDF. So if we label what we know that BE is 15. Okay. We also know that AE is 9. DF is 12. And CF is 20. So if I look at my 2 triangles, it looks like we have 2 sides and an included angle. We know their lengths. So if I want to know these 2 triangles are similar, it's going to be by side, angle, side similarity. So we already have the included angles being congruent. Now we just need to show that the corresponding sides are proportional. So we're gonna, looking at our picture, BE corresponds to CF and AE corresponds to DF. So we want to look to see that those 2 sides are proportional. So plugging in our lengths, we have 15 over 20 equals 9 over 12. So we can either simplify both of these fractions to make sure the ratios are the same, or we can use our cross product. If we cross multiply, we should get the same value, and then we know the sides would be proportional. So we're going to do 15 times 12 equals 20 times 9. And 15 times 12 is 180, and 20 times 9 is also 180. So we get 180 equals 180, which means our sides are proportional. So we have 2 corresponding sides proportional and an included angle congruent. So we have that triangle BAE is similar to triangle CDF by side, angle, side. It's also important here that when we write a similarity statement, we can also determine by which similarity the 2 triangles are similar. In our second example, we're given that RS is parallel to TU, RS is 4, RQ is x plus 3, QT is 2x plus 10, and UT is 10. we want to find RQ and QT. So first we have to determine whether our two triangles are similar, because if they're similar, then the corresponding sides will be proportional, and I can use that to solve for the side lengths. So it comes back from the fact that RS and UT are parallel. So because those lines are parallel, I can think of the segment RT as my transversal. So using that, I can say angle R is congruent to angle T because they are alternate interior angles. And we also look, angle RQS is going to be vertical to angle TQU, which means we have a pair of vertical angles, and vertical angles are always congruent. So we have two pairs of corresponding angles congruent, which means our triangles are similar by angle-angle similarity. So we know that triangle RQS is similar to triangle TQU by angle-angle. And from similarity, we know that the corresponding side lengths will also be proportional. So I can set up a proportion to help us solve for X and then RQ and QT. So we know that RS corresponds to TU, so we have 4/10. And then we know that RQ, which is X plus 3, will correspond to TQ, which is 2X plus 10. So I have my proportion that I'm going to use cross products to solve. So product of the extremes, so 4 times 2x plus 10 equals the product of the means, 10 times x plus 3. Distributing into our parentheses, we'll get 8x plus 40 equals 10x plus 30. Subtract 8x from both sides. We get 40 equals 2x plus 30. And then subtract 30 from both sides, so we get 10 equals 2x. And our last step, divide by 2 from both sides, and we get that x equals 5. But we are not done, because the problem asks us to find the lengths of RQ and QT. But now that we know what x is, we can find those lengths easily by just plugging our value in. So we have RQ, which equals x plus 3, so we get 5 plus 3, which means RQ has a length of 8. And then to find the length of QT, which is 2x plus 10, we get 2 times 5 plus 10, which becomes 10 plus 10, so that QT has a length of 20. And we can always check to see that we found x correctly by plugging RQ and QT into our proportion and checking to see that the cross products are equal. Our last example is a word problem. So we have that Josh wanted to measure the height of the Sears Tower in Chicago. He used a 12-foot light pole and measured its shadow at 1 p.m. The length of the shadow was 2 feet. Then he measured the length of the Sears Tower's shadow and it was 242 feet at that time. What is the height of the Sears Tower? So I'm going to draw pictures to help us with this. So we have a 12-foot light pole. And I cannot draw. So we have a light pole. This light pole is 12 feet tall. Its shadow was measured. So its shadow comes down to the ground. And then the distance from that base of the light pole to that point was 2 feet. Now we have the Sears Tower, which I'm not even going to attempt to draw. We don't know its height, x, but we know the length of its shadow at the same time was 242 feet. So we have two triangles here. And anytime you have a height of an object and then you do the length of its shadow, going straight out from the base of that object is going to create a right angle. So we have two right triangles with congruent corresponding angles. So these two triangles are going to be similar by side angle side. So we want to set up a proportion to help us solve for the height of the Sears Tower. So we have the height of the light pole is going to correspond to the height of Sears Tower, which we don't know. So we have 12 over x equals the length of the light pole shadow, which is 2, corresponds to the length of the Sears Tower shadow, which is 242. So to solve for the height of the Sears Tower, we're going to cross multiply. So we get 12 times 242 equals 2 times x, which becomes 2,904 equals 2x. Divide both sides by 2, and we get x equals 1,452. So we know that the height of the Sears Tower is 1,452 feet. And if you were to look up the height of the Sears Tower, you would actually see that it's 1,453 feet tall. So our proportion was actually pretty accurate in solving for the height of the Sears Tower. Okay. So in these last two examples, we want to determine if the following pairs of triangles are similar, and if so, which theorem was used, and write the similarity statement between them. So either by angle-angle, side-side-side, or side-angle-side proportionality. So if we're looking at our first picture here, we have triangles DUE and TUS. So because we're given two side lengths and we don't have the necessary information to solve for the third, we're going to want to use side angle side similarity. And angle DUE is congruent to angle TUS because they are vertical angles. So we do have a pair of corresponding angles congruent. We have angle DUE is congruent to angle TUS. So now all that's left to do is see if the corresponding sides are proportional. So that would be checking to see that DU over TU is equal to UE over SU. And if that proportion holds, then the triangles are similar. So DU has a length of 16, TU has a length of 40, and then UE also has a length of 16, and SU has a length of 39. So looking at our ratio, we can already tell that these two triangles are not going to be similar. 16 over 40 does not equal 16 over 39. But we are going to use our cross product just to double check. So we have 16 times 39 equals 16 times 40, which gives us 624 and 640, which are not equal. So even though the triangles may look similar, they are not actually similar because the sides are not proportional. So we actually have that our triangles are not similar. Which means we're not going to write a similarity statement and we're not going to have a theorem that told us which one we used. Our last example, we have a triangle within a triangle. So if we look, we're talking about triangles KBC and triangles KLM. And because both triangles share that angle K, that's going to be our congruent angle in each triangle, because angle K is going to be congruent to itself. Because it's a shared angle, it's going to be the same measure in both triangles. So we have our congruent angle. Now we just need to see if we have proportional sides. So we have that KB corresponds to KL, and then we have KC corresponding to KM. So if the proportion is the same, then we're going to have similar triangles. So we need the length of KB. So KB has a length of 16 over the whole side KL, which has a length of 88. It's going to be equal to the length of KC, which is 25, over the length of the whole thing. So if we notice, we're not actually given KM. We're given KC, which has a length of 25, and we're given CM, which has a length of 107. So we're going to add those two numbers together to give us the length of the whole side, which is going to be 132. Now we use our cross product, so we get 16 times 132 equals 88 times 25. 16 times 132 is 2,112. And then 88 times 25 is 2,200, which are not the same number. So we don't actually have similar triangles. So looks can be very deceiving in these last two examples. Even though two triangles may look to be similar, it does not mean that they are. So we actually have again that our triangles are not similar. So let me know if you have any questions over the notes, and while you're working on the example, on the assignment, please ask for help if you need it.